Hello dear students, welcome to Karna Maths Academy. Today in this video we are going to discuss one of the most important chapter, which is the probability theory. In this video we are going to discuss the basic terms related to probability, which are random experiment, sample space, event, and on the basis of these three basic terms related to probability, we can easily define the mathematical definition of probability, which is also known as Priori or classical definition of probability. So before we discuss the different terms related to probability and the mathematical definition of probability, let us know what is the history, what is the background of the probability theory. Dear students, in mathematics we study statistics, trigonometry, algebra, geometry. Likewise, probability is also a branch of mathematics. Probability is also a branch of mathematics in which we numerically study the chances of occurrence of events. Probability is a branch of mathematics in which we numerically study the chances of occurrence of events. Dear students, it originated from gambling, but now it has become so rich and developed that it is being used in different branches of engineering, such as information theory, control theory, ship behavior in navigation, etc. Dear students, now let us discuss what are the basic terms of probability. What are the basic terms related to probability? The first basic term related to probability is random experiment. Without knowing random experiment, we cannot define sample space, we cannot define event. So random experiment is the first basic term related to probability. So before we define what is a random experiment, dear students, let us take some examples of random experiment so that it will be easy for us to define what is a random experiment. Dear students, if we toss a coin, if we toss a coin, we know that a coin has two sides. The first side is called head and the second side is called tail. So if we toss a coin, we cannot say whether head will appear or tail will appear. We cannot say whether head will appear or tail will appear. There is no rule to know it. So tossing a coin is an example of random experiment. When we throw a die numbered from 1, 2, 3, 4, 5, 6. When we throw a die numbered from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It is impossible to say which number will appear. There is no rule to know it. So dear students, tossing a coin, throwing a die are the examples of random experiment. Likewise, we get several examples of random experiment. Now we can define what is a random experiment. An experiment is said to be a random experiment. An experiment is said to be a random experiment if its outcomes cannot be predicted. That is, the outcomes of a random experiment does not obey any rule. So the experiments like tossing a coin is an example of random experiment because we cannot predict the outcomes of a coin when it is tossed. Similarly, throwing a die is an example of random experiment because we cannot know whether the phase 1 will appear, or phase 2 will appear, or 3 will appear, or 5 or 6 will appear. So these are the examples of random experiment. Now the second term related to probability is sample space. Dear students, already we know what is a random experiment. An experiment whose outcomes cannot be predicted. The outcomes of a random experiment does not obey any rule. So let's go to the second term related to sample space. The set of all the possible outcomes of a random experiment. When we toss a coin, there are two possible outcomes, head and tail. Either head will appear or tail will appear. So there are two possibilities, or we can say there are two possible outcomes when a coin is tossed. So dear students, sample space is the set of possible outcomes of an experiment. As we know that probability theory is based on set theory. So on the basis of set theory, we can define what is a sample space. A sample space is the set of all the possible outcomes of a random experiment. So when we toss a coin, the possible outcomes are head and tail. So the sample space is H, T, the set of head and tail. Dear students, sample space is denoted by the letter S or the Greek letter omega, and the number of elements of sample space is denoted by ns or n omega. When a die is thrown, then the possible outcomes are 1, 2, 3, 4, 5, 6. Any one of the pairs may appear. So there are 6 possible outcomes. So S is equal to the set of the 6 numbers 1, 2, 3, 4, 5, 6, and the number of sample space is equal to 6. Likewise, when we draw a card, when we draw one card out of 52 cards, then the number of sample space will be 52. The number of sample space will be 52. The number of outcomes is equal to 52. Now let's discuss what is called event. Dear students, we have already the concept of sample space. So event is subset of sample space. Every subset of sample space is known as event. Every subset of sample space is known as event. If a card is drawn, if a coin is tossed, then the sample space is H, T. The number of sample space is 2. The subsets of the sample space H, T are H, T, null set, and the sample space itself. So when a coin is tossed, the sample space is the possible outcomes head and tail. So number of sample space is 2, and the subsets of sample space are as the set containing H, the set containing T, null set, and the sample space itself. So these are called events. Every subset of a sample space is called event. Event is generally denoted by the letter E, and the denoted by the letter E or A, B, etc. And the number of elements of event is denoted by any. So dear students, event is the subset of sample space. The number of event is equal to 2 power n. The number of event where n is the number of elements of a sample space. So if there are two elements in a sample space, then the number of elements in the event will be 2 power 2, that means 4. Similarly, when a die is thrown, then the sample space is 1, 2, 3, 4, 5, 6, and the number of sample space is equal to 6, and there will be the number of events will be equal to 2 power 6, that means 64. So there are 64 events when a die is thrown, because the number of sample space is 6. As we know that event is any subset of the sample space. So if there are 6 elements in a sample space, then there will be altogether 2 power 6, that means there will be altogether 64 events. So dear students, we know what is a random experiment, what is a sample space, and what is called event. Now let us discuss the types of event. The first type of event is simple event, which is also known as elementary event. If a coin is tossed, then the sample space is H, T, and in this case there are 4 events. The first event is H. The first event is H. The second event is tail. The first event, which indicates the appearance of head. Second event, which denotes the appearance of tail. The 2 events E1 and E2, they are called simple events. Simple events are those events which contain only one element. So we can say that singleton set is known as simple event. That means subset of sample space which contains only one element is called simple event, which is also known as elementary event. Now let's go to the mixed event. The mixed event the third event is known as mixed event because it contains more than one element. So the event which contains more than one element is known as mixed event. Now let's go to the null event. The null event is the event which does not contain any element, any element. So it is known as null event, or we can say impossible event. The fourth event is the null event, or it is also known as impossible event, because the number of elements in the fourth event is equal to 0. Dear students, when we toss two coins, then the sample space is Dear students, when we toss two coins, then the sample space is the combination of the sample space of first coin and the second coin. So when we toss two coins, then the sample space will be h comma h, s comma t, t comma h, t comma t. So there are 1, 2, 3, 4 possible outcomes. So when two coins are tossed together, then the sample space there are 1, 2, 3, 4. There are 4 possible outcomes. The number of sample space is equal to 4. Now the event, first event h comma h, the first event h comma h indicates that the first we get h from the first point, and again we get h from the second point. That means we get head on both the coins. The second event h comma t indicates that we get head on the first coin and tail on the second. Dear students, now let's discuss what is called sure event and certain event. The sample space is itself a subset, which is also known as sure event, or we can say certain event. Now let's discuss equally likely events. Those events whose chances are neither less than or greater than the other events are called equally likely events. So when we toss a coin, the chance of getting head or the chance of getting tail are equal. So tossing a coin, the outcomes which we get tossing a coin are equally likely events. Likewise, when we throw a die, number 1, 2, 3, 4, 5, 6, then any one of the number will have equal chance of appearance. So the possible outcomes when we get after throwing a die are called equally likely events, because each and every event has equal chance of appearance. Let's define the mathematical definition of probability. Dear students, the probability of an event E is denoted by PE. That means the probability of event E, if NE be the number of elements of the event E and NS be the number of sample space. If NE represents the number of elements of the event E and NS be the number of sample space, then the probability of event E is denoted by PE, and it is defined by PE is equal to number of E by number of S. So this definition of probability is known as mathematical definition or priori, or it is also known as classical definition of probability. Dear students, hello dear students, the mathematical definition of probability, which is PE is equal to probability of event E is equal to number of event by number of sample space, is true only if the events are equally likely events. That means the possible outcomes are equally likely events. The number of elements in the sample space is finite. That means if the number of sample space is infinite, then we can't use the mathematical definition of probability, and if the probability of event is a rational number, then only we can use the mathematical definition of probability. So in order to define the mathematical definition of probability to solve the numericals of probability, we must be sure that the events are equally likely events, the number of elements in the sample space are finite, and the probability of event is a rational number. So only in three conditions we can use the mathematical definition of probability. So it has got limitations, so we must be very careful while finding the probability of an event. So dear students, before we come to the end of this video, let us recall what we have discussed in this video. So at first we discussed what is a random experiment. An experiment is said to be a random experiment if its outcomes, that means results, cannot be predicted. The outcomes of a random experiment does not obey any rule. Secondly, we discuss sample space. As we know that the probability theory is based on set theory. So the sample space is the set of, that means the collection of all the possible outcomes of a random experiment. All the possible outcomes of the set of all the possible outcomes of a random experiment is known as sample space. Event, every subset of sample space is called event. And we discuss the different types of events, like simple event having only one element is called, the event having only one element is called simple event. The event having more than one event are called mixed event. Null event, the event which does not contain any element is called null event or impossible event. Sure event, the sample space, it is also a subset, so sample space is called sure event, or we can say certain event. And equally likely events, those events which has neither greater nor which has neither great, those events which has neither greater nor less chances of occurrence are called equally likely events. And probability, the mathematical definition of probability is the ratio of number of event to the number of sample space, which can be used only when the events are equally likely events, the number of elements in the sample space are finite, and the value of probability is rational number. So thanks for watching this video till the end. This is more in detail in the next part of this video. Thank you. Keep on watching Karn Academy.